437 pass some number 3. Given the root of a binary tree and an integer target sum, return the number of passes where the sum of the values along the path is equal to target. The path does not need a start or end at the root or a leaf, but it must go downward. So what is happening here? We need to traverse this tree and see if we can find nodes with values that their summation is equal to target. So in this example, we start from 10 and we go downward and we have 8 here, and we go to the right, we have 8 here, and the summation of these two is 8 too. So we are going to return 3 passes exist that their summation is equal to 3. What are the cases here? When we traverse in the tree, we might start from the root and we go downward and their summation is equal to target. That's one way. Another situation is when we are along the path and the summation of some values there is equal to the target. So there are two cases here. The first case is the summation from the root. Summation from the root is equal to target. The second case, that's something that is make it complicated and we need to deal with that, is the summation between the path is equal to target. So this is what's making it complicated. So for traversing this tree, we need to traverse it all the way down. So we cannot traverse it like level by level, because it says we should go downward only, right? So what comes to my mind is DFS traverse, like for traversing the tree, and we are going to use pre-order, because the pre-order goes all the way down and then goes all the way down to the right, and then it goes all the way down to the right and then right. So it reads the root and then left and right. So we need to have a DFS function, right? Which I'm going to give it like the node that we have, I'm going to give it to it. And what we need to know here is we are going to use a dictionary. Why are we using a dictionary? Why are we using a hash map? We are using a hash map to keep track of the summations along the way, and this way we can find these special cases. So what I'm going to have here, I'm going to have a hash map, and I'm going to use collections default dictionary. The reason is, if we don't have that value that we are looking for in the dictionary, this type of dictionary doesn't return an error. It gives us 0 if we don't have that value, and it will create that value in the dictionary with value 0. So for example, if we have a dictionary, something like, let's say 1, 2, and let's say 4, like 1, and I'm looking to see if I have the value 2 in it, the key 2 in it, it doesn't return an error. It adds the value 2 with the key 2 with value 0, and it doesn't return an error, right? So this is something about the default dictionary that we need to know. And what we are going to do, we are going to do a DFS, a pre-order one. I'm going to say if not node, if we don't have node, we are going to return 0, right? Because we are doing the summation, we don't need null. When it returns null, I cannot add null to like any value. It's not an integer, so I need an integer. So I'm going to return 0, and then I'm going to have a count, which is going to keep track of the number of paths that we are going to have. And then I'm going to have a current summation of the path that I'm going down. So I will start with, I will give the current summation from the beginning to the function, because I'm going to call this function recursively. I'm going to say the current summation, we said it's going to be a pre-order, right? So we are going to say node.val, and then I am going to say, deal with the first case. I'm saying if the current summation that I have is equal to target, just simply add 1 to the count so we know one pass exists. But for the special case, for the second case, that is something that is make it more complicated. We are going to use the hash map that we just created here. What is happening here? For the second case, it means the current summation is not equal to target. What we are going to do, we are going to say count is equal to the hash map of the current summation that I have minus the target. If I have this value in the dictionary, so it means we are in the middle of the way, right? And then we are going to return the number of nodes that we have with this summation. But if we don't have it, it's going to return 0. So it's going to add 0 to the count. And you are going to say, how are we going to build this hash map? Every single time that we have a current summation, I'm going to add that to the hash map. Current summation is going to be added to the hash map. Every single time I'm going to add it to the hash map. I add 10, I add 15, I add 18, I add 21. And then I will add all the summations that I'm going to do. And then I'm going to say count plus equal the DFS. I'm gonna call it for the left node, and I will pass the current summation, and also I will give it for the DFS for the right node, and I will pass the current summation, right? And after doing that, after traversing the tree to the left and right, I need to remove that value from the hash map. The reason is, like, when I change the branch, I don't want to have a confusion with the summation that I have here and return wrong result. So I'm going to remove that current summation from the hash map. When I go through an example, you will better understand this situation. So I'm going to return the count, and I need to call the DFS function with the root value that I have, and the summation we start from 0. Now let's go through an example. Let's see, let me run the code first and see if we get any errors or anything. So I have 2M here, so we should be careful about the typos and these kind of mistakes. So what we have here, we have the first case and we have the second case. So it's giving me an error here, and I need to figure it out. So note if it is returned 0, count 0. Oh, I forgot to add a plus here. It's not doing the summation here, so it doesn't make sense. There we go. So now we have it. Now let's go through an example, the same example that we have here. So I'm going to have a hash map, which is start with like an empty hash map, and then I am going to have a current summation of is equal to 0 when we start, and then I'm going to have the count, which is going to start from 0. And let's run the code and see what we are going to have. Let me print out the hash map that I have here. So it's going to be fun to see the hash map. Okay, there we go. Let's see. Let's start with the example that we have here. So what is happening here is we start from the root node, which is 10. And then I check, okay, it's not an empty node and the count is 0. I'm going to add that to the summation. So it's going to be 10 here. And I compare 10, is it equal to 8? It's not equal to 8. So I'm going to check if we have it in the hash map. 10 minus target is going to be 2. And we don't have 2 in the hash map. What is happening here? It's the beauty of the default dictionary. It's going to add 2 with value 0. So it's going to add 0 to the count, right? Which is almost like it's exactly nothing. And then we are going to add the value, the summation that we have 10 to the hash map and add 1 here. So this is how we keep track of things here. So let's say when I get here 10, 15, 18, and when I say 18 minus 8, which is the target, is 10. And if I find it here, I know, oh, this is along the path, and I'm gonna add 1 to the count, right? So, and then I will check, now I need to start to go through all the way to the left, right? So what is happening here, we are going to call it for the left node, which is 5, and the current, which is 10 now. So I call it for 5. 5 is not empty. I'm going to add it to the summation. Now it's going to be 15. 15 is not equal to 8. So I check if 15 minus 8 is 7. It's in the dictionary. So it's not in the dictionary. I'm just going to add it here. And then I'm going to add the 15, and I will assign 1 to it, right? And then I need to call the left node again. So it's going to be 3 this time. We check it's not empty. We are going to add that to the current summation. So it's going to be 18. So 18 is not equal to target, but 18 minus target, which is 8, is going to be 10. Do we have 10 in the dictionary? Yes, we do. What is happening here? We are going to add 1 to the count, right? I'm going to add 1 to the count, and then I will say the hash map of the current, which is 18, is going to be equal to 1. And I need to call the next left, which is another 3. So it's not an empty. I'm going to add it here, which is going to be 21. And we say 21 is not equal to 8. We check if 21 minus 8, which is 13, it's in the dictionary. It is not in the dictionary. It's just going to be added with value 0. And we are going to add this 21 in the dictionary with 1. And we go to the left. We go to the left, and it's null. So if it is null, it's going to return 0. So it's going to recursively call them all. And now we go for the, it's here, now it goes to here because it goes recursively. So it's going to be minus 2 here. So it checks if minus 2 is not empty. No, it's not an empty null node. So it's going to deduct it from here, right? And it keeps doing that and doing that until we have a dictionary, something like this, and it will return the results. So the time complexity for this is going to be linear, because we have to traverse the 3 minimum ones.